Good evening, students. I once again welcome you for the workshop part 2 on non-ferrous metals and alloys. So in the part 1, we have learned about the types of brass. Before that, what are the uh, non-ferrous metals? What are the properties and applications of non-ferrous metals and non-ferrous alloys? We have so far studied about the types of uh, brass. So in this workshop part 2, we are going to learn about the remaining non-metal, non-ferrous alloys. First of all, we are going to see about the bronze. Bronze consists of copper and tin. It is looking as dark yellow color, and it is more endurance than brass, and it is very much high corrosion resistance and very fluid when melting. So it is very capable of good for molding. Then applications of bronze. So bronze is widely applied for valves, valve seats, bearings, and gear wheels. So it is very much applied in IC engine valves and valve seats. Then it is widely used in underwater fittings and also used for statues and medals. Then bronze is also used for making ship propellers and for making belts, gears, bearings, and statues, as in the diagram. So it is a metal alloy consists of primarily of copper and tin. So since it is mixing with tin and copper, it is a hard and brittle material. It has very high resistance to corrosion. So its melting point is 950 degrees Celsius. So it is widely used for making statues and medals also. So in the bronze, apart from copper and tin, zinc may be present in the small amount. So types of bronzes is aluminium bronze, tin bronze, beryllium bronze, and silicon bronze. So first of all, aluminium bronze. As the name itself, most percentage of metal is copper, and very less percentage of aluminum. That is 4 to 11 percentage of aluminum is mixing with copper. So other elements also added such as ferrous, nickel, manganese, and silicon. So the very much properties of aluminum bronze is good strength, ductility, toughness, good bearing properties, good corrosion resistance, and good fatigue resistance. So most of the applications of aluminum bronze are jewelry, cigarette cases, heat exchangers, chemical plants, pump castings, valve fittings, propellers, cylinder heads, gears, dies, bearings, spark plug bodies, and electrical contacts. So second one is tin bronze. So as the name itself, most amount of most percentage of metal is copper and very less percentage of tin. That is 8 percentage or 8 to 12 percentage or 12 to 20 percentage of tins are mixing for different applications. Then next one is gunmetal. So gunmetal consists of 88% of copper, and 10% of tin, and 2% of zinc. So gunmetal is widely used for gun barrels and ordnance pots, marine castings, gears, bearings, valve bodies, and similar applications. Next alloy is copper nickel alloy. So as it names, copper is mixing with nickel. High percentage of copper and very low percentage of nickel is mixing for this alloy. So copper nickel alloy has the properties of ductile, malleable, and can be worked both in cold and hot conditions. The corrosion resistance increases with increase in nickel, and also the copper nickel alloy has tensile strength, fatigue strength. It increases with nickel. The applications of copper nickel alloys are used for thermocouple wires, locomotive fireboxes, marine condensers, turbine blades, bullet envelopes, and coins, then resistance wire, valve pots, pump rod liners, impellers, and part in chemical industries. And mainly the copper nickel alloy is used in costume jewelry. Then next one is solder. So solder is another one metal, that is non-ferrous metal. It is a fusible metal alloy used to join together metal workpieces and having a melting point below that of the workpieces, and having a melting point. It is an alloy of lead and tin. So solder consists of lead and tin. So solder is used for electronics, plumbing, jewelry making, and repair processes where metal parts cannot be effectively or safely welded. So most of you are seeing the soldering. So soldering is mainly done for electronic parts and electrical parts. So solder consists of tin and lead. So its melting point is 200 degrees Celsius. So in the photocopy, we can understand that how the soldering is done by using this welding. So it is an alloy of lead and tin. So as I told, it is used for electronics, plumbing, jewelry making, repair processes where metal parts cannot be effectively or safely welded. Now we are moving on to aluminium. So before that, we have studied copper and its alloys, then brass, bronze. Now we are moving on to aluminium. So the aluminium is a white and lighter in weight than steel and copper. It has high corrosion resistance. Aluminium has good machinability, formability, and castability. Duraluminium and Y alloy are the very important aluminium alloys. So before learning about the duraluminium and Y alloy, the common applications of aluminium, that is are widely used in aircraft and automobile industries. So these are all the properties of aluminium. Aluminium has large growth in use since 1950. It is a abundant metal, that is 8% of Earth's crust. It is a lightweight, and it has the specific gravity of 2.7. It is moderate to high strength depending upon the alloys. It has high conductivity. It has high corrosion resistance, and it is reflectivity high, and it is a non-magnetic. So aluminum is obtained from bauxite by the Bayer process, and aluminum oxide is reduced electrolytically by the Herold process to make the aluminum. So the large energy requirement for this process is the major proportion of the cost of aluminum, even with cheap energy sources. So the graph indicates the work hardening process of aluminum. So in the next slide, we are going to study about the case hardening for making aluminum alloys. Before that, the properties of aluminum. It is light in weight, good thermal and electrical conductivity. It remains ductile and tough up to 40 degrees Celsius. Non-magnetic, it has excellent ability of getting alloyed with other elements. So main applications of aluminums are cooking utensils, combs, collar buttons, toasters, and mixers. And also, it is widely used for making electrical conductors, food containers, paint, nameplates, ashtrays, flower pots, coins, bicycles, motorcycles, trucks, and buses. And main part of the airplanes, that is aircrafts, are manufacturing by aluminum, and marine vessels are also making by aluminum. So these are the different types of aluminum alloys. First of all, deformable and heat treatable aluminum alloys. That means these aluminum alloys are under the heat treatment process before going to machining. So the types of heat treatable aluminum alloys are duraluminum, which consists of aluminum, copper, magnesium, and forgeable aluminum that consists of aluminum, copper, magnesium, and silicon. Then corrosion resistant aluminum alloy that consists of aluminum, magnesium, and silicon. And high strength aluminum alloy that consists of aluminum, zinc, magnesium, and copper. Then heat resistance aluminum alloy that consists of aluminum, copper, magnesium, nickel, and ferrous. So thus, the most of the percentage of this aluminum alloy as aluminum and very small percentages of other metals. Then deformable and non-heat treatable aluminum alloy. That means it will not be subjected to heat treatment process. Directly, it can be machined without heat treatment. That is, first one is aluminum and manganese alloys. Second one is aluminum, magnesium, or magnesium alloys. Then plain bearing alloys. Bearings are mainly used by making aluminum alloys. That is aluminum, lead, and aluminum nickel, aluminum copper, and SB. Typical structure of bearing materials. So, up- upon the different types of alloys, we are going to learn duraluminum. So, duraluminum is an aluminum alloy which contains magnesium, manganese, copper, and silicon in small percentages. It is a lightweight metal with a high tensile strength and good resistance to corrosion even in seawater. Duraluminum is mainly used for making bars, sheets, and rivets. Automobile and aircraft parts are mostly making by duraluminum, and portable ladders, door and window frames are also making by using duraluminum. Then Y alloys. Y alloy is also one of the aluminum alloy. It consists of 4% copper, 2% nickel, and 1.5% magnesium, remaining that is almost 93% aluminum. So properties of Y alloys are excellent ability to retain the strength at elevated temperature and with fairly good corrosion resistance. And it can be easily cast and rolled, but it is chiefly used in the cast form. So applications of Y alloys are It is mainly used for pistons and cylinder heads of diesel and high duty petrol engines. So then next one is enduminium, or it consists of 5% copper and 1.5% nickel and very small percentage of manganese, titanium, Sb, cobalt and zirconium. So properties of enduminium are creep resistance. Applications of enduminium are it, it is mainly used for making parts of the aeroplane or aero engines. So different vehicles and different parts in the as the figure are manufactured by aluminum and aluminum alloys. So before going to making the different required shape, the aluminum alloys are under the precipitation hardening. It is one of the heat treatment process which is used for aluminum alloy. So in the precipitation hardening, first of all, the aluminum alloys are heated with particular temperature that is above the critical temperature. Then it is cooling, and finally it is under the AG. So in this graph, we can understand that first of all, the aluminum alloys are solution treating. It will be subjected to some additives and it will be heated up to 500 degrees Celsius below the low critical temperature. Then it is slowly cooling by using quenching process, that is dipping in cooling medium such as cooling water or coolant oil. Then it is under the aging process, that is slowly then slowly heating and finally cooling. Then the quenching process consists of the dipping the component by using water. Then aging is done by naturally aged 20 degrees Celsius, and again it will be under the cooling. Now finally we will learn about the advantages and disadvantages of ferrous and non-ferrous materials. So for non-ferrous materials, its advantages is mainly it can be used in areas that produce magnetic fields, and non-ferrous materials are mainly it's having resistance to corrosion, so it can be easily used according to the weather conditions and moisture, for example structures and vehicles. Mainly non-ferrous metals are also much lighter, that is light in weight, and making them well suited for use where strength is needed, because they contain no iron, and non-ferrous metals have a higher resistance to rust and corrosion. So mainly non-ferrous metals are used for making gutters, water pipes, roofings, and road signs. Finally, they are also non-magnetic, which makes them perfect for use in small electronics and as electrical wiring. So we have very much known about the non-ferrous materials, that is copper, types of copper and copper alloys, that is brass, bronze. Then finally, we have learned about the types of aluminum alloys. So far, we can very much known about the non-ferrous materials. So thank you so much for your patient watching. Thank you.
Thank you so much for watching the video. Make sure you've subscribed so that you can get the regular updates. Use the feedback ink in the description to get your certificate. Thank you.